So hello, today I'm going to talk about the IPC specification for plated through hole and how to calculate the pad size and what exactly given in IPC 2000 and 6000 series regarding the plated through hole. So what basically IPC stand for? It stand for Institute for Interconnecting and Packaging Electronic Circuits. Previously, when it was formed in 1957, it was known as Institute for Printed Circuit. So what basically IPC do is they are a global trade association for electronic and interconnection industry. So they publish the specification and standards on a regular basis for electronic products. The basic idea is that all the electronic products are developed according to certain standards for the safety, reliability, and high quality of the PCB products. And and design engineer and the fabricator are on the same page. So what IPC basically did, it has categorized all the electronic product in three category: class 1, class 2, and class 3. So you can go through that. I'm not going to explain in detail, just will give you the overview what is basic difference. So under the class 1 comes all the general electronic products like TV remote control, LED lights, and the electronics which comes in the kids toys, where the reliability of the product is a critical factor in this type of board. Then IPC class 2, under this comes the dedicated service electronic products like laptop, smartphone, tablet, communication equipments, so on and so forth. So in this case, uninterrupted service is preferable but not critical. Products are also not exposed to the extreme harsh environmental conditions. Third class is class 3. Here you have a high reliability, and these products are also exposed to the very harsh operating working conditions. So such kind of electronic products come under the class 3. These products are basically life support system, then military equipment, electronic monitoring systems, and automotive. So in automotive, most of the products come under this category. Important thing is that for class 3 product, they must provide a continuous performance on demand, also under the harsh environmental condition, which is from minus 40 till 150 degree. So it depends on the product, but that's the range. So IPC standards, as a PCB design, as a electronic design engineer, at least you should know this IPC standards or specifications like IPC 2000 series, then 7000 series, then 6000 series, and also the 600 and 610 series, which is important for the design engineer. And there are also other lot of IPC standards, which is for the PCB production and regarding the assembly material, stencils, shouldering, then shoulder mask, copper foil, packaging, storage, test methods, so on and so forth. You can have a look here. But these are the left side. These are the PCB specifications which should known by every electronic engineer. So basically, this is in this specification, like in series 2 IPC series 2000. Here they have defined the design, and the land pattern specification is given for the component pads, SMD or TST, or for the vias. Then this is in 610 or 600 is acceptability of electronic assemblies, and in 6000 you have a qualification for printed circuit board. Then IPC specification for plated through hole via. So via are basically a critical part of every PCB design and are responsible for transmitting electrical current between the layer, which is used to connect the different layer. So here on the right side you can see the picture of the via. According to IPC class 3, via should consist of following four things: external and internal annular rings. Here you can see that this distance is called the external annular ring, and this one is the internal annular ring. So this is the via, which is on a 4-layer PCB. This is the top layer, mid layer 1, mid layer 2, and this is the bottom layer. So according to if you are designing a product for class 3, then it should have a external annular ring of 50 micrometer and internal annular ring 25 micrometer. Then it should have the via plating. This is the via plating, which is also known as a via barrel, and the thickness of via barrel should be minimum 25 micrometer. Then minimum fabrication tolerances, which is the while manufacturing the drill bit are not so precise, or the PCB manufacturer has its own machine tolerances and it's around 200 micrometer. And then via drill, which are used like 0.3 millimeter or 0.4 millimeter, so it depends. And important thing is that aspect ratio, it is recommended to maintain a 8 to 1 aspect ratio between the hole diameter and the via length. As per the specification, this aspect ratio 10 to 1, but it's always better to restrict to 8 to 1. Otherwise, the PCB manufacturer cannot guarantee you the via, which is fabricated by the PCB manufacturer, fulfills the class 3 requirements, which means that all these requirements what is given in the specification. So that's why this aspect ratio is very important. Then the next part, here you can see that what exactly the annular rings are. This is extra annular ring. This is the via pad size, and this is actually the via hole or plated through hole. And this portion is called the minimum annular ring, and that you can also see here. And this is the external annular ring, and internal annular rings is here on the internal layer. So the specification, the minimum specification what is given for plated through hole is internal supported via, they should have 25 micrometer, external should have minimum, external annular ring should be minimum 50 micrometer. And here you can see that in the specification they have given for class 1, class 2 and class 3, but class 1 and class 2 are having an exception, but class 3 doesn't have any kind of exception, which means that on the for the class 3 type of product, you should have the internal and external annular ring of this specification. You should meet this specification. Otherwise, those products are not uh, qualified for the series production. So here you can see that this is a 6-layer PCB, and this is a external annular ring, and this is the internal annular ring. In the IPC specification, it's mentioned that your class 3 should have 50 micrometer of external annular ring that the PCB manufacturer should fulfill for the class 3 PCB. And for class 2 and class 1, well, this is the pad size where the via is drilled. In that case, even if the drill bit is not registering at the center of the via, and if it shift because of the tolerances in the fabrication or manufacturing equipment, then for class 2 it's allowed breakout of 90-degree. Here you can see that the 90-degree is from the center of the hole till the edge of the pad. So this is the 90-degree. That is allowed for the class 2. And for class 1 type of component, if the drill bit comes not at the center of this pad, instead of that on the edge of the pad, that is fully allowed. But in case of class 3, you can see that from all sides it should have at least 50 micrometer annular ring on the external layer and 25 micrometer annular ring in the internal layer. So that's what the specification is. Here, as I said, that now we talked about the external and internal annular ring, then I will go for the via plating, and this is what the via plating is. Here you can see that in the 4-layer PCB, uh, this is the external annular ring, and this is here, these are the internal annular ring, and this portion from here till here, this orange portion, which is here you can see the measurement of D7, D5 and D3, that is called the via plating on the left and the right. And for class 3, the thickness of this via plating is defined, and here you can see that, which is also called a surface plating. So copper minimum average for class 3 25 micrometer, and minimum thin areas is 20 micrometer. So which means that wherever the thin area is there, so it's allowed 20 micrometer. So these are the minimum requirement, not the maximum, but the minimum requirement. Keep in mind. So here you have a 19.6 micrometer, here 21.1 micrometer, and 19.6 micrometer. Here they are mentioned in inches, but you can convert from inch to micrometer. So these are basically the others are blind vias, micro via, buried vias, and so that you can have a look. But today I'm only talking about the through holes. So how we can calculate the path size for, let's say, 0.3 millimeter diameter via. So there is a formula which is given in the IPC specification, and the formula says that it's if you have to calculate this plate size, then the formula says the minimum path size formula is A plus 2B plus C, where A is the maximum diameter of the finished hole. Then the B is for a minimum annular ring requirement. So here you should not forget the each pack, that should also be included. Yeah, but if we will take here the in between this drill size more than the diameter what you need, like 18 to 100 micrometer, then it's already covered. Then the C is the minimum standard fabrication allowance, which is 200 micrometer. Then all these are the standard specific. These screenshots are from the IPC 2000 specifications. So for level 1 is class 1, level B is class 2, and level C is class 3. So for you can see that for class 3 it's 200 micrometer tolerances for the fabrication or manufacturing allowance, which is minimum here, if you will see, because those are the most precise PCBs or products. So that's why. And the rest here for class 2, it's allowed till 250 micrometer, and for class 1, 400 micrometer. So suppose you want to place a 0.3 millimeter diameter via in class 3 product. So what you can, we will put the values in the formula for the internal layer, minimum path size, and the external layer. So let me start with the external here, this one. And so 0.3 is basically the diameter what we need of the via. Then 0.3 plus I took 80 micrometer for the drill size, which you need for the plating. Basically, this side and this side, this plating for the vias. Here, I'm not taking the drill size of the drill bit, but I'm taking here the the size of the diameter of the hole what I need on the PCB. So 0.3 plus inside I have to also do the plating. So then this is the external annual ring requirement, 2 times multiplied by 50 micrometer, and plus this is the manufacturing tolerances. So it will come around 0.68. And when I will put the value in this equation for internal layer, then the pad size for the 0.3 millimeter diameter is 0.63 millimeter. So that's how you can calculate the value as per the IPC specifications, and you can send it to your PCB manufacturer, and he should fulfill. And when he will give you the PCB test report, then you can check all this measurement, whether this plating is according to this specification or not. Then this annular rings are external and internal are according to the specifications or not. Yeah, I hope this video is useful for you. And if you like this video, then please subscribe to my channel. In next video, I will come with more IPC specifications. Thank you very much and have a nice day.